Hi everyone, today I'm going to discuss the solutions for Atcoder Beginner Contest 3A2, problems A to E. Let's look at problem A. For problem A, we have n boxes arranged in a row, and some of the boxes contain cookies. Over the next D days, Takahashi will choose one of the cookies to eat each day, and after D days, we need to know how many of the n boxes are empty. And a dot represents an empty box, and this symbol represents whether the box has a cookie. And we can just simply loop through the entire string and count how many of the boxes have cookies. And afterwards, we subtract the number by D, and we'll have the number of boxes that have cookies. And we can just use n and subtract the number from n, and that will be the number of boxes that are empty. Let's look at the code for this problem. For this problem, we just loop through the entire string and keep track of a count, which is the number of boxes that contain cookies. And afterwards, we subtract D from the count. And now we have the number of boxes that contain cookies after D days. And the answer will just be n minus count, which is the number of boxes that are still empty after D days. For problem B, we still have the same problem, but now Takahashi will take the cookies from the back. So we just have to loop through the string, and this time backwards, and each time we see a box that contains a cookie, we can take the cookie out and replace the string with a dot. And after we change D boxes, we can output the answer. Let's look at the code for this problem. For this problem, we input the string as a character array, so we can easily change one character and output the result. And we loop through the array backwards, and each time we see a box that is occupied, we can change the character to a dot. And we will subtract D by 1. And after we change D such boxes, we will have taken out D cookies, and we can output the answer. By looping it from backwards, we will ensure that all the cookies at the end will be taken out first. Next, for problem C, there are n people that is visiting a sushi restaurant, and each person has a gourmet level AI, and n pieces of sushi will be placed on the conveyor belt. And each piece of sushi also has a deliciousness BJ. And as the sushi passes in front of the people in order, if the deliciousness of the sushi is greater than the person's gourmet level, then the person will take the piece of sushi. And for each of the pieces of sushi, we need to determine who eats the sushi. For problem C, let's first look at a sample test case. For example, if there are 3 people and 5 sushi dishes, and the gourmet level of the people are 3, 8, and 2, and the sushi will go in the conveyor belt in this order, which is 5, 3, 1, 4, 2. And for the first dish, since it has a level of 5 and the first person only has a level of 3, then the first person will take the sushi. And for the second dish, the first person will also take it. And for the third dish, nobody will take it since it is lower than any of the people's gourmet level. And for dish 4, the first person will also take it. And for dish 5, the third person will take it. And so we realize that if we loop through the people in order, since the dishes go from the first person to the last person, if it is already greater than the first person's level, then the first person will take it. Therefore, we need to loop through all the people in order. And we realize that A1 is 3, and anything greater than or equal to 3 will be taken by the first person. So we can just sort the dishes by increasing order, and this will become 1, 2, 3, 4, 5. And if we loop through array A, then anything greater than a 3 will be taken by the first person. And afterwards, anything greater than an 8, but there is nothing greater than 8, so nothing will be taken by the second person. And for the third person, anything greater than or equal to 2 will be taken by the third person. And afterwards, the remaining ones will just be -1. So if we want to quickly find the value that is greater than or equal to AI in array B, we can just do binary search. And let's look at the code for this problem. For this problem, we first input all the values, and for array B, since we're going to sort it, but in the end we want to output the answers in order, we need to keep track of the array in pairs and record the index in the second element of the pair. And we can sort array B in increasing order, and afterwards we will loop through array A. And for each person, we do binary search to find the value in B that is greater than or equal to AI. And afterwards, we will update anything between A and the end of between J and the end of the array that hasn't been updated yet. And this part, we will change the answer array, which just records who eats the dish, to I+1. So anything between J and the last update will be changed to person I+1. And afterwards, when we output the answer, anything that hasn't been updated will become -1, and we can print out the answer. For problem D, we have integers n and m, and we need to create integer sequences of length n that ends with m, and for each element, the element before it plus 10 must be less than or equal to the element. So there needs to be more than or equal to 10 between the numbers. And for this problem, since all the values are small and n is only equal to 12, we can just directly output every possible combination. I did this by storing the possible solutions into vector of vectors. So for the first part, I put all the possible starting numbers in an array answer. So this part I'm just checking if with the minimum difference of 10, if it is still possible to have a sequence of n numbers if I start with I, and if not, I will just break. And afterwards, I will loop through I to n-1 and add n-1 numbers into my answer array. So for this loop, I will loop through all the possible current starting vectors. And for each one, I will assign it to vector A, and afterwards I will start with a difference of 10. And for each value, I will insert it into the current vector and push it to another vector called answer2. And in this if statement, I'm checking if with the current leading numbers, if it is still possible to have n numbers in my sequence if I add k to the next number. And for answer 2, I am pushing in all the possible leading sequences with the new term added in it. And afterwards, I will swap answer and answer 2. I will assign answer 2 to answer, and I'll clear answer 2 so that we can push in new arrays for the next round. And afterwards, answer will contain all the possible sequences, and we can just output all of them. If we visualize what I just did in the code, then we can look at the sample input. For the sample input, I will first add all the possible starting numbers to answer. And in this case, there are 1, 2, and 3. And in each loop, I will add another number to all the arrays. For example, when we add the second number, I will add 11, 12, and 13 with behind 1 and insert these vectors into answer 2. And after I add all the possible combinations of the first two numbers into answer 2, I will assign answer equal to answer 2, and I will clear out answer 2 so we can push in the third round of numbers into answer 2 next time. And we can just repeat this process until all of the n numbers are added. For problem E, we have an infinite number of packs, and each of the packs contain n cards, and the ith card is rare with a probability of pi%. And whether each card is rare is independent of the other cards being rare, and we need to find the expected value of the number of packs we need to open if we want to find at least X rare cards. And let's look at the algorithm for this problem. We can solve this problem with dynamic programming, and Fij will represent in one bag, and if we only look at the first I items, what is the probability that out of those I items, J items are rare? And this DP will transition as follows. For the first section, we consider if I isn't there, then there is a probability of 1 minus pi that I isn't there. And since I isn't there, the first I minus 1 items must contain j rare items. So we multiply it by the probability that there are j items in the first I items. And afterwards, this part is if I is rare, then there is a pi probability that I is rare. And we will only need j minus 1 rare items in the first I minus 1 items. And we create another DP, which is the answer that we want to compute. So dpk will represent the expected number of bags that we still need to open when we need k rare items. And dpk would transition like this. If there are no items in this current bag opened that are rare, then that occurs with the probability of fn0. And since none of the items are rare, we will still need k rare items, so we multiply this by dpk. And for each I from 1 to n, if I items are rare, then this occurs with a probability of fni. And since I items are rare, then we will only need k minus 1 items. So we can multiply this by dpk minus I. And if we move this term to the left, then we would have 1 minus fn0 times dpk is equal to this. And so we can obtain dpk by dividing the sum with 1 minus fn0. And in the end, dpx will just be the answer that we want to find. And let's look at the code for this problem. So for this problem, we first input all the p values, and we initialize. Since my index starts from 1 to n, we can initialize f10 as 1 minus p and f11 as p1. And afterwards, this transition will just be the same as what I just mentioned. And for fi0, we need to multiply 1 minus p by fi minus 1, 0, because none of the items will be chosen, and that probability will just be 1 minus p. And for the calc_dp function, calc_dp is just, we can calculate the dynamic programming with recursion and store that in a dp array. So for each of the I from 1 to n, the sum is fni times calc_dp k minus 1, k minus I. And we need to increase the sum by 1 already, because this means that we already opened another bag. And so at the end, so I think the previous the previous transition that I mentioned, I didn't add 1 to the sum, so we need to add 1 to the sum, because this means that we already opened one bag. And in the end, dpk will just be the sum divided by 1 minus f and 0. And the answer we need is just dpx. So we can output the answer. And yeah, we need to notice that this part, we opened one bag, which I think I got wrong in the transition that I mentioned.